Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to be talking about expanding binomials, continuing our unit on connecting graphs and equations of quadratics. So today we're going to learn how to turn the factored form of a quadratic relation into what's called standard form. And we'll do that by multiplying binomials. A binomial is an algebraic expression that has two terms, so x and 1. Each of these is a term, and because there's two of them, we call them binomials. And when we're multiplying two binomials together, we have to expand and simplify that expression to turn it into one more simple expression, which we will call standard form. So to start off, I'll ask you to see if you can draw what's called a diagram using algebra tiles, and then express the area of the rectangle that is made using that tiles using another algebraic expression. So here is the expression that I want you to try to use algebra tiles for. If you have some on hand, that's great. If not, which I imagine many of you don't, I'm going to help you out just by starting us off with a diagram. Okay, so this is what the diagram looks like. I'm taking x, which is some unknown length, and I'm multiplying it by x plus 1. So this length and this length are the same. And when I multiply two things together, it's almost like I'm making a rectangle, right? That's the length, that's the width, and the rectangle that's formed in here will kind of look like this. Now I know that this distance right here, let's call this the width. The width is x plus 1. The length is just x units long. And so the area of this rectangle will tell us when I multiply x times x plus 1, the area of this rectangle will be the same as my answer there. So how do I do that? Well, the first thing I'm going to do is wherever there's a break in between the algebra tiles, I'm going to cut my rectangle along that line. Now it's a little bit more manageable because now I can see that the area of this square here is x times x, or simply x squared. And the area of this tile is x times 1, and x times 1 is just x. So the area of the rectangle is the sum of these two pieces put together. If I add them together, I will get x squared plus x. So in other words, my algebra statement is going to be x times x plus 1 is equal to x squared plus x. The length times the width gave me this area of x squared plus x. This is how we use algebra tiles, and we'll use this in our lesson today. So to start off, you can use any graphing software you want, but see if you can graph these two expressions using whatever software you want, including Desmos or a graphing calculator, and then make a statement, a mathematical statement about your findings. It should take you maybe 2 or 3 minutes just to graph them, and then maybe 1 more minute to figure out what is the statement, how are these two things related? So you can go ahead and pause the video right now, and then for maybe 2 minutes, and then come back to the take up. So this is what these two equations look like, these two expressions. When we graph them, this red one creates a parabola with the zeros at -4, -2, and a vertex of -3 and 1. And notice that this expression does the exact same thing. Well, what does that tell us about these two? It tells us that they are equal. That is the mathematical statement. This is equal to this. Well, if both of them are the same, how can we turn this one into this? It's sort of like Tony Stark and Iron Man, right? When we say the word Tony Stark, that means the same thing as when we say the words Iron Man, because both those two are referring to the same person. Well, if I look at this algebraic expression, it's referring to the exact same thing as if I say this. And I just need to know, how do I turn one of these into the other? How do I turn this into this? Let's start by using algebra tiles. So this is saying take x plus 4, that could be something like the width, and let's multiply it by x plus 2, and that could be like a length. When we multiply two things together, it's sort of like taking length times width. The area of the rectangle that we create is our answer. So let's look at x plus 4 first. This is how I would describe that. X, and then 1, 2, 3, 4. And then the length would be x plus 2. X plus 1, 2. Now the rectangle that is created by this would fill up all of this space. What is the area of this rectangle? Well, just like we did in our minds on, what I'm going to do is I'm going to cut this rectangle into little strips according to wherever there's a break in my algebra tiles. So right there, there, and there, I'll cut those open. And I'll also cut it here because I do see some breaks here as well. Now, how did that help me? Well, I could find out the area of each of these pieces and then add them together to find the total area. So for example, this piece right here, x times x gives me x squared. For this piece right here, 1, that's the length. The width of this piece is x from up here. So this is 1 times x, or x times 1, which is just x. And this idea follows for this piece as well, right? X times 1, this is x. And it'll follow for this piece as well. This has a width of 1 and a length of x. So 1 times x is still x. And that will apply for these as well. All of these long tiles are the same area of these two tiles over here. And finally, the last tiles over here, what is the area of this tile? 1 times 1, length times width, will give me an area of 1. Each of these are the same area, and they can all be found by taking the width of 1 and multiplying it by the length of 1 as well. So all of them are 1. Now, how did this help me find the multiplication of these two? And did it help me turn it into this? Not quite yet, but we're almost there. So I'll take that x squared. To it, I will add all of these x's, right? Because that is the area of each of these tiles. And I will also add the area of all of these square tiles down here. In total, when I add all of these up, what do I get? Well, I've got x squared. I've got, and that's exactly what I had here, right? I had one x squared term. I had 6 x's, and look, 1, 2, 3, 4, 5, 6. I've got 6 x terms. And finally, I have 8 ones. So I have 8 tiles that have an area of 1 each. So the total area here is x squared plus 6x plus 8. And I got that just by using algebra tiles to make a rectangle, cut it into pieces, find the area of each piece, and then just added them all up to get this. Let's do this one more time, but instead this time what I'm going to do is I'm not going to cut it into pieces because that might get a little bit like into as many pieces because that might get a little bit annoying. Instead, I'm going to do it still with algebra tiles, but I'm going to say x plus 4 is x, and then this is just 4 units long. And then x plus 2, I'll do the same thing. I'll say, okay, this is x, and I'll say this is like 2 units long. And this way, I only have to cut my rectangle into 4 pieces, not, how many did I have before? 15 pieces? I don't want 15 pieces. I only want 4 pieces. So I'll still cut along here, and I'll make a cut along here as well. Now the area of this tile, pretty easy, x times x is x squared. What is the area of this tile going to be? This has a length of 2 and a width of x. So x times 2 is just 2x. What is the area of this tile? A width of 4, a length of x. 4 times x, that's just 4x. And finally here, what is the area of this tile? A width of 4 and a length of 2 tells me it is 8. 4 times 2 is 8, length times width. Okay, did that really help me out at all? Well, yes, now if I add together these four terms, x squared plus 2x plus 4x plus 8, I'll get x squared, that's this tile, and that's exactly what I have here. 2x plus 4x gives me a total of 6x. And finally, just 8 down here. That's 8. So I've done this without breaking it up into as many algebra tiles as before. In general, when you are multiplying two binomials, you will find yourself in the exact same situation every time. You'll be able to make a rectangle and cut it up into exactly 4 pieces. This first piece will always be multiplying the first two terms, right? X times x. So let me take that f here and move it over here, because this term will always be the multiplication of the first two terms, x and x. This will always be the product of the outer two terms, which is why I'll take this O for outer, and I'll move it here. So O is for outer. So this was 2 times x. 2 times x. Those are the outer two terms. This term here will always be the inner two terms. So I'll put an I right there. So this is 4 times x, right? That's how I got it. 4 times x is 4x. And finally, this term right here is going to be the last two terms. So I'll label this with an L, and that is 4 times 2, the last two terms. The last one in this binomial and the last one in this binomial. And 4 times 2 is 8. So here, this gives me an algebraic expression. If I multiply the first two terms, the outer two terms, the inner two terms, and then the last two terms. And then I just collect my like terms to create a simplified algebraic expression. So when you're multiplying two algebraic expressions, what you have to do is multiply every term that is in the first expression by every single term in the second one. Do that all separately and then combine them. Today we looked at binomials, which have expressions with only two terms. Now, we can use this rule to multiply trinomials as well. But for now, let's just stick to binomials. When you're expanding binomials, we just follow the same rule over here, but binomials have an easier way to remember them using the hint FOIL. When you have two binomials, which remember, a binomial is two things being added or subtracted, so a plus b and c plus d. When you're multiplying these together, you will multiply all of these in order. So the first two terms are a and c. So a times c. Then you'll do the outer two terms, which are a times d, which is ad. Then you'll do the inner two terms, which is b times c, or bc. And finally, you'll do the last two terms. This is the last one. This is the last one. B times d is bd. And then you'll just add them all up together. And whatever you end up with once you've simplified that expression, that will be your answer. You have successfully turned two binomials, the product of two binomials, into a simplified standard form. Let's look at an example of this. Convert this to standard form. Now I could make my algebra tiles and stuff, but instead I'm just going to follow the rule that I figured out. So I'm going to do 2x times 3x. Those are the first two terms in each binomial. 2 times 3 is 6. X times x will be x squared. But I'll get to that later. Now I'll do the outer two terms, 2x and 2. So that's 2x times 2. Now we'll do the inner two terms, -1 times 3x. And finally, I'll do the last two terms, -1 times +2. What do these end up equaling? Now, after I do this, I do have to add them together. So 2x times 3x is going to be 6x squared. 2 times 3 is 6. X times x is x squared. 2x times 2 is going to be 4x. 2 times 2 is 4 with just a single x. -1 times 3x is -3x. And finally, -1 times 2 is -2. The last step I have to do here is actually combine any like terms. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.